Production was crawling, but nothing looked busy. Customers could browse products and manage their carts, but when some of them tried to place an order, checkout waited about 5 seconds and failed with a 504. So I gave the incident to my AISRE investigator. The first checks made this interesting. Health was returning 200. All 3 replicas were available, 0 restarts, and checkout CPU was only around 9 to 13%. Memory was stable. No OOM events, no CPU throttling. Customers were failing, but the application wasn't overloaded. Then the database showed something suspicious. CPU was at 74%. At first glance, that looked like our answer. But after normalizing the metric, actual usage was only about 0.15 of a CPU core. Completed queries were still finishing in around 12 milliseconds. Database CPU wasn't the bottleneck. So the AI traced the failed requests instead. Every timeout stopped during inventory reservation. The request waited almost exactly 5 seconds. No order was created. Payment was never reached. Then a pattern appeared. Every failed checkout involved the same promoted item, promo 441. Other products were still completing normally, so this wasn't a checkout-wide slowdown. The investigation moved into database connections. 3 checkout replicas, 10 connections each, 30 active, 0 idle. Every available database connection was occupied, but pool exhaustion was only a symptom. The AI inspected what those connections were doing. All 30 sessions were waiting on the same transaction. That's why CPU stayed low. The system wasn't busy doing expensive work. It was blocked. The investigation traced the blocker to one PostgreSQL session, PID 1842, owned by reservation-worker, and its state was idle in transaction. Now the failure started to make sense. The worker had updated the inventory reservation for promo 441 and then lost an upstream response. The AI inspected the cleanup path. Rollback called false. Connection closed false. There was the root cause. The worker returned without rolling back the transaction or releasing the connection. That transaction stayed open and held the row lock. Checkout requests queued behind it until all 30 database connections were occupied and customers hit the 5-second timeout. Healthy pods, low CPU, fast health checks, but production was crawling because the requests weren't working. They were waiting. The connection pool was the symptom. The retained lock was the blocker, but the actual defect was transaction cleanup that never ran. Case number 4. Production was crawling and nothing looked busy. Follow the automated SRE for the next investigation.